Hello there, my name is Ismas and welcome to another exciting Blender tutorial, and today we're going to be doing one of those satisfying videos that you see on Instagram and Facebook. So yeah, Ducky 3D and CG Geek did something like this, and the interesting thing about it is that every one of them approached the project differently and added their own twist. I think CG Geek used keyframe animations to make the loop or the animation of the satisfying video, and then Ducky 3D used the particle system in his project. So my twist is going to be using the physics rigid body system, as that's what I usually like using for most of my animation. So let's go in and see how to create a satisfying video. So let me delete this cube, and let me also turn on my keys here. And okay, then add a torus. So I already have a concept in mind. What I want is let me just delete these top faces and also delete this middle edge loop. Go to the modifiers here, add a solidify modifier. And so the concept I have in mind is I want this to swing around like this, and then have a metal ball swing the opposite direction as this is swinging. So let me shade smooth and add a bevel here, reduce the offset and limit the bevel angle to 30 degrees, something like that, so that we have only the sharp edges having the bevel. Also, let me add a subdivision surface modifier so that we have a smooth surface. I want this edge to be sharp, so I will increase the segments here to 2 so that I have a sharp edge. I can see that this inside divot here, or trench, whatever you want to call it, is have this sharp angle here, and that's because the angle between these two edges is more than the threshold we set for the limit method here. So let me increase that to something like 45 for the bevel so that we have that smooth, and you can see what we have. Let me turn on random colors and cavity here so that we can see the shapes more clearly, and I'll move this above the grid so that we have something like this. Again, my concept is to have a spherical object like this kind of roll on this surface as this swings around as well. So to do that, we're going to use the rigid body system. So let's just go to that and set this as a rigid body system. If we play back, it will just fall down. We want it to be swinging on something here, so I'm going to add a cube somewhere like that, and have it set to a rigid body but type of passive so that it stays in place. And now I can use an empty to create a rigid body constraint. That way I can tie this or fix this object to this object. So we can select this as object 1 and then this as object 2. Now if we play back, you can see that this is no longer falling down, but if we remove it from this constraint, it means that it's no longer fixed to this empty, so it will just fall down. I want it to be fixed, but I also want it to be able to swing, so that if I move this, let me just rotate this from the 3D cursor. So if I let this go, it should swing from up here to this side, and but because right now the rigid body constraint we have set is set to fix, which means that we're simply welding this object to this other object using this as the rigid body constraint, meaning it won't be moving anywhere. So if we want it to move, we need to change the constraint type from fixed to something else, and for this we can use hinge or point. So what point lets you do is let this swing freely in all axes, and just show you. After some time you'll see it swinging around the Z axis, but that won't really work well for what we are trying to go for. So what I'm going to do is use the hinge type so that we lock the axis of rotation here. I can see if I play this, I see that we're not getting the rotation we need here because we have a hinge constraint. That means it's limiting the axis of rotation to one axis, and right now we have the wrong axis, or the empty is facing a different direction. So we need to get the right orientation for this, and I'm switching this to an arrow so that you can see where the hinge is facing. And right now, because it's facing up, we're not getting the correct rotation. So if I rotate this on the x-axis, you can see now it swings in the direction we want. That's what we want to go for, we want to have. Now I also want this, just have it somewhere here, to swing within this torus. So let me give this a rigid body system, playback. See, it's bouncing off this object because Blender, when you're using rigid body systems, it tries to optimize the simulation by creating optimized collision shapes. So for an object like this, instead of using the object itself, which is in this shape, as the collision shape for this object, meaning that this object would be able to settle here, it's optimizing the collision shape to be in this shape so that the simulation doesn't take a lot of CPU power. That's why you can see that it's ejecting this this ball from the inside of this, because it's detecting that as an artifact and creating an error. So we will need to change the collision shape of this object to respect the shape of the object. Instead of using an optimized shape, we wanted to use the actual shape of the object we are having, which is this shape here. So let's first clear this. Just clear that. Then select the torus, go to the shape and change it from convex hull to mesh, and then hit play. You can see now the collision shape is exactly what we want, what we are going for. Sometimes you will notice that this here, the ball, is not really touching the endpoint or surface of this torus, and that's because, again, Blender is trying to optimize the simulation by reducing the number of polygons it's using for the collision. So for this sphere, if you wanted to collide with the surface of this shape, we would need to change the collision shape from unoptimized collision shape to the actual shape of the mesh, which is just changing the collision shape from convex hull to mesh. But you can see we have a few other different shapes we can use here, and we have a spherical collision shape that can work really well for this sphere without using the base or the actual shape of the mesh. So it means that it will use the optimized version of the shape, but also give us more a high fidelity simulation. So if we play back, you can see now we are getting this surface contact on both objects. So right now this is what we have, but because of physics, this object is just swinging in the middle like that. But I wanted this ball to swing up to this side, meaning that I want this to swing all the way to this side so that the ball is resting at around this corner. So something like this. If I have this object here, I want the ball to be here. So, and if I have this swing this side, I want the ball to be somewhere like here. So we need to create a mechanism that will allow this to swing all the way, allow this to swing all the way to there, and allow this to swing all the way to here. And right now physics doesn't really allow for that because because of drag and other forces, and this will start losing its swing and start settling down. But we want this to be an infinite loop, so we want this to be continuously swinging around. So let's go back. Let me just remove these notes for a second. So to have that swing continuously, what we're going to do is weld most forces here, or another shape with a different weight. So if I add a cube here and add an empty, give this cube a rigid body constraint, a rigid body system, and give it a mass of 100 degrees. Let me put this actually up here, so that if I weld this weight to this object, this weight will force the swing this side, and I'll have another force here, so that when this swings up to this side, this force should push the swing back this side, and I will animate the weight of these objects, so that when this swings up to this level, this weight increases to about 10 kilograms to push this force down here, and this other weight, as this is around here, it starts when it's at this level, it would be at 10 kilograms, and when it swings back here, this reduces its weight from 10 to about 1, so that this force can push it back up. Otherwise, if we keep it at 10 and this at 10, it will just create it will be in equilibrium, so it won't be able to swing back and forth. But if we animate those weights to reduce and increase depending on where the swinging is swinging, you can have this swing continuously and infinitely. So let's do that. And so to weld these objects, I can see we have this cube here. Again, I have the constraint already. If I play back, it's just falling down. So I need to weld it directly onto this other object. Let me put it here so that the ball doesn't collide with it. So put it here and add a fixed rigid body constraint to it. Now you can see that because of the force we have, it's pushing the weight is too high. Let me just set it to 10. It's pushing this all the way and almost flipping it over. I think that was a nice animation. But we don't want it to go all the way, so we are going to add another force on this opposite side. You can see I've copied this force with its own with its empty or constraint, so that it stays attached to this empty. So we have this force and this force. Now this swings, and then this counters whatever swing we have from here, and we have something like that. But because we have the same weights on the opposite side all the time, this will come to equilibrium and then settle in place, which is something we don't want. We want this to be to go on continuously forever. So we are going to be animating these forces so that when this is high, we increase it to 10 kg, so that it can push this swing down and reduce the weight or mass of this to 1, so that it can allow for this to push it all the way this side. So let's animate that and see how that looks. We put this on this side. Okay, so let's first animate this weight. When it's at this level, I want it to have a mass of 1 kilogram, and then when it swings to about there, it should still have a mass of 1 kilogram, because we want this force to be able to push it all the way up there. But after a few frames, it should regain its mass of 10 kg, so that it can push this back up. And now here, for this here, let me first go back to this frame here. So at around this frame, this should have the mass of 10 kg, and then at this frame, its mass should be reduced to 1, so that it can allow for this to push it back. And so we would have that swing up to somewhere like there, somewhere like there. Again, you want it to have that 1 kg up to there, and then regain its mass, something like that. Okay, let's see if make sure I didn't animate anything else. So this should, okay, I'm not sure why this has moved away from its original position. It should be something like that. Okay, so this is countering this force too early, so I'll push it back somewhere like here. Okay, See, something like that. Now it's coming to a stop because the animation is stopping. But now we can just add a cycle if curve modifier to have this go on continuously. So let me see. So it starts here at a mass of 1, goes up to here with a mass of 1, increases its mass, and then it should push this to around frame 80 with that mass of 10 kg, and then the cycle repeats for that. And now let's check out this. So it starts with a mass of 10 kg, goes to 1, goes to 1, then the cycle begins. Okay, so I've done some experimenting, and this is what I've come up with. So instead of using two forces here, one force or one mass on one side and another mass on one side, I found that it is easier to explain and easier to work with if you only have one mass and only increased the mass of that object. So when you increase the mass of this object, it should push this swing this side, and as the swing swings up to this side, you reduce the mass of this object to something less than 1 kilogram, so that this swing can swing back this side. And then again, if it gets to this height again, you increase the mass and push it back down here. This is what I'm doing here using these keyframes, and I've changed the keyframe interpolation from linear to constant, so that I can easily drop the mass here very quickly. And you can see that right now we have a mass set to 6 kilograms, and it pushes this up to here, and then the mass drops significantly here to something like 0.001, and then it swings back. Then here, as it's about to swing back, I increase the mass to get that. So it allows for an interesting kind of animation. So you can see that it even creates a bit of tension in the animation that might be harder to achieve with keyframe animation. You can see now it's like this ball is about to drop, and then we get that. But right about here, yes, the ball falls off, and we still want to catch it. So I have to adjust my keyframes here. So I want to right around here, because this mass is, see, this mass has now swung up here, and it's still at 0, 0, so it's continuously going up. So if I bring that mass back up right about here, and it should start pulling the swing back so that we can capture that ball before it drops off. So let's see what we have here. I think this is a very good exercise to learn about the physics system in Blender, and you can see now. Did we get that? Okay, so we are about to capture it. Let me first turn off these layers. See, get the animation. We pick it up. It swings up. So another thing we can do is maybe drop the mass right. You can see it swings too high and throws the ball outside the net. So just going to right around here, just drop the mass. So you're just only animating one object, and the rigid body is helping you animate. So we are losing some of the momentum that gives us that tension. So what I'm going to do is just readjust these keyframes just a bit and see what we are getting. See how it captures that. Okay, so it nearly catches it, then loses it. Maybe we'll just reduce the weight here. Let's see. Yeah, exactly. That's what we want. So let me increase my timeline to something like 300. Let's see. Let me try this again.